could take any one of those and kind of go do your own business. And I think that's why the biotech space is growing at 28%, right?
Yep.
The biotech space is, they're tied directly into our medical spending in this country, which is kind of out of control.
Well, and I can see it. I mean, that's a nutty one. But the same dynamics are at work in a lot of other markets. When you look at polymers, not the same growth rate, but the same market dynamics seem like they work there.
Yeah. And it's strange because particularly those two, semiconductor and biotech, the ops manager from NanoString in Seattle was the ops manager for a polymer spin coating company for Intel that sold to Intel, right? So these are small kind of little groups that kind of stay together, right?
Right.
And now Intel and that semiconductor, the volume there is enormous, right? That's $48 billion of kind of sales on that stuff. And it's crazy. I can't tell you the amount of time at Intel that I would say stuff like, we're going to order in extruded aluminum and we're going to order them in thermal plates. And then somebody go, okay, our projected volume on these servers and these, consumer desktop parts are over the amount of aluminum produced in the world annually. And go, right? And it's the same problem, by the way, that Ford had when they went to the F-150 and put in an aluminum frame. I don't know if you followed that at all. Right?
Well,
they went away from a steel, and then they're like, we don't have enough aluminum to do this.
I designed, back when I was at Michigan doing my PhD, after I got out, I did body structural design for Ford. So, yeah, I know that problem real well. Yeah. Fascinating.
And so it's a very interesting market, and it seems like every mode in the biotech, so next generation sequencing, just like real-time PCR, just like acoustic microscope, seems to have about the start of a technology and then about 10 years of a cycle.
Yep.
And then after that, they're replaced by something new, or the market focuses down on something. So instead of the whole genome, they're just going on exome, or they're going around protein-based, or they're going around just certain markers, or they're going around cell therapy. And you see node after node pop up from that. And then nodes like real-time PCR and PCR dying. And a lot of the specialty chemicals, you'll see them going from real-time PCR plates on film coatings and coverage to the second year in a next generation sequencing system. Right. So that you see a lot of this same, kind of cyclical path.
Yep.
So,
by the way, having looked at thousands of different markets, different time scale, but that thing happens in lots of markets where you get multi-year cycles like that, and then the new thing comes along. The old thing doesn't completely die, it just kind of fades away. Depending on the cycle, some markets, they die slower than others. There's some that are really different. If you ever want a crazy one, the stent market for about 20 years would do radical changes, but that's pretty unusual. Most of the markets move not too dissimilar to what you're describing.
Here's a question for you, seeing as you've studied this a little bit, that I've always wondered about. The Great Recession we had in, you argue whether it's 07 or not 09 kind of time frame, that took all the markets down all at the same time. Does that mean that from now on, the semiconductor and the biotech downturn are going to be combined? Did that actually put those now on the same cycle?
Probably not. I think there's two things. I think there's macroeconomic drivers, and then there's market-specific drivers. So the issue is that when the macro drivers move, they move everything, right? So in that case, it was crazy derivative bets on housing, which led to taking the macro drivers down globally. There's also market-specific things. An example would be aerospace right now, which is aerospace growth rates, even notwithstanding overall growth since 2009, aerospace growth rates are unsustainable, as are biotech growth rates most likely, right? Because